Given the equation of a curve in terms of k, where k is a constant, part A, find the value of x at which there is a stationary point in terms of k. So in order to find the stationary points, we need to find the derivative dy dx first. Where we differentiate, we have negative k, 3x minus k to the negative 2 times 3. Remember to use the chain rule, plus 3, so that dy dx is negative 3k, 3x minus k to the negative 2 plus 3. Stationary point occurs when dy dx is 0. Setting dy dx to 0, we have negative 3k over 3x minus k squared plus 3 is 0. Rearranging, we have 3 equals 3k over 3x minus k squared. Now these two can switch place so that 3x minus k squared equals 3k over 3, which is k. Taking square root on both sides, 3x minus k is plus minus square root k, or we have 3x equals k plus minus square root of k. Isolating x, dividing throughout by 3, we have x equals 1/3 k plus minus square root of k. This will give you the values of x where there is a stationary point. The function f has a stationary point at x equals k. Fx is given by 4 times 3x minus 4 to the negative 1 plus 3x. We need to find the value of a and to determine the nature of the stationary point. There is only one single value of a. If you compare y and fx, you will see that k is 4. So when k is 4, fx is actually the same as y. Only thing now is k equals 4. Then the stationary point is x equals 1/3. K is 4. We have 4 plus minus square root of 4. So this is 1/3. 4 plus minus 2. 4 plus 2 is 6. Divided by 3, we have 2. And we have 2 over 3. Now this is inadmissible because x must be greater than or equals 3 over 2. Then we say that a must be 2. This is the stationary point. To determine the nature of the stationary point, we can always look at the sign of f prime x. dy dx is given, we found dy dx from part A here. So what happened now is when we replace k with 4, we have f prime x. So that is negative 3k. We have negative 12 over 3x minus 4 squared plus 3. We only need to look at the sign diagram of f prime x. And that occurs when x is 2. So we have x equals 2. When x is less than 2, let's say x is 1. Find the value of f prime x. You should get a negative value. Now let's say x is 3. To the right of 2, if you replace x with 3, we see that f prime x is positive. A negative and a positive, meaning that at x equals to 2, there is a minimum. So we say that there is a local minimum here when x is 2. Part C, the function g is defined for x greater than or equals to 0. So if we compare y and g of x, we see that k now is -1. You want to determine whether g is an increasing function, a decreasing function, or neither. Whether a function is increasing, decreasing, or neither, we can check from the derivative. So we look at g prime x here. Again, we look at this part of the function where you have dy dx here. Replace k with -1, so -3k is just +3. 3 over 3x plus 1 squared plus 3. This is always positive. 3 is always positive. The sum of two positive numbers is always positive. We say that g prime x is greater than 0. Since the domain is defined for x greater than or equals to 0, we say that g prime is greater than 0 for all x greater than or equals to 0. And this implies that g of x is an increasing function.